Hi bachos, Indu ma'am is back. So today we will continue with the chapter of motion, and our topic for this video will be displacement and distance. Okay, let us understand them one by one. Displacement. So when you change the place of a body, for instance from here to here, then I have displaced the pen. So displacement is simply a change in the place of a body. Well, but it matters. You need to know the direction. If this were you, अगर ये आप होते, तो if I told you that move by 2 steps and you moved here, 1, 2. I could have scolded you. Who told you to move there? You were supposed to move here, this way. That means for displacement, you need not know only 2 steps. You need to know the direction also. Do you remember? When you need the magnitude as well as the direction, we call it a vector. In that case, displacement becomes a vector. It is a vector quantity. So displacement is change in position, and since you need to know the direction of the change, we will be considering it as a vector. Now, let us talk about distance. Let us throw a little more light on this matter. Well, let me tell you, we are 4 friends living at the 4 corners of a society. This is me, Indu, Bantu, Chintu, and Dinda. We live at 4 corners of the society. Each is 1 kilometer away from each other. So, in my city, to travel 1 kilometer, the auto rickshaw charges 20 rupees. So, I know to go from my place to Dinda's place, I have to pay rupees 20. So, I decided to go to meet Dinda with 20 rupees in my pocket. Well, but I had to give some things to Bantu and to take some things from Chintu. So, I went, instead of going from here to here, I decided to go to Bantu. I gave her the things which I required to give. I went from Bantu's house to Chintu. I took the things I wanted, and this was the shortest way. So I reached Dinda's house. And then the rickshawala, the auto rickshaw driver, he told me, give me 60 rupees. I said, what 60? He said, why not? I said, I know, to come from my house to Dinda's house, I have to pay only 20 rupees. So what are you talking about? 60 rupees. Do you think he is right or wrong? Well, just pause the video and think over it again. Yes, I have come just 1 kilometer away from my house. Dinda's house is 1 kilometer away from my house. So the displacement, the change in my position is from I to D. 1 kilometer. Then what is this? It is the length of the path I took. I could have taken this path, which I am depicting in green. I could have taken this path and paid rupees 20. But I chose to go this way, the longer way, because I had some tasks to accomplish. So the distance covered by the rickshaw driver is more. It is 1 plus 1 plus 1, 3 kilometers. So actually he is not wrong. For covering these 3 kilometers into 20, I have to pay him 60 rupees. So although my initial and final positions in case of green and red path would be same from Indu's house to Dinda's house, but the distance I took is more. So let us understand these words again. Displacement is the change in position. आपका initial position, आप शुरू में कहाँ थे, and your final position. इनके बीच में जो shortest distance है ना, भले आप कैसे भी जाए, whichever way you take, that is the displacement. The shortest distance between your final and initial position is called displacement. So मेरा displacement to 1 kilometer था. मेरा final position और initial position के बीच में जो shortest distance था वो 1 kilometer था. But मैंने path कौन सा choose किया? I didn't take the green path. I chose the red path. So इसकी जो लंबाई है, the length of the path which I took while traveling by rickshaw, okay, was Indu to Bantu, Bantu to Chintu, Chintu to Dinda. Okay, so the distance traveled is the length of the path taken by me. So it's like 1, 2, 3. Okay, so that is the distance. Distance is 3 kilometers. So in distance, it doesn't matter whether you are to my left or to my right. It doesn't matter. If you are 2 steps away, you are 2 steps away. I never asked you in which direction. So distance does not require any direction. So distance is a scalar quantity. Distance is a scalar quantity. So I would repeat myself. Displacement is the change in the position. It is a change in the position. So in which direction did you change the position is really important, and hence it is a vector. And this distance is the length of the path taken by the body. So let us put the things together. Let us try to define them. So as we discussed earlier, displacement, it is the shortest. I would like to draw your attention to the word shortest. इसको चेक करने के लिए आप इसको कितना ध्यान दे रहे हैं. A good few questions can be asked. Okay, it is the shortest distance between the initial and final position of a moving body. Fine? And this distance, it is the length of the path. आप कौन सा रास्ता लेते हैं? Path. Traveled by a body. So here, which path do you choose? The longest, the shortest, it depends upon that. Whereas this does not depend upon the type of path you choose. It is just आपकी दोनों position. First कहाँ थे और last में कहाँ है, right? Apart from this, obviously we know, we discussed earlier, displacement is a vector quantity. It is a vector. I would like to remind you, it is TOR, quantity. And this, it is a, again spelling, SCALAR, quantity. Okay, and let me tell you, eventually it is the shortest distance, whatever, but it is a type of distance. So the similarity is in दोनों के units same होंगे, they will have the same unit. Generally, while solving sums, we use the SI unit, that is a system international. So we will write the SI unit is meter. centimeter. And for practical purposes, when the distance is too long, you will also find kilometer. Well, so this can be asked in multiple ways. They can ask you to define scalar, to define displacement, to define distance, to write the difference between the two points. So you have the definitions in blue, and whether they are a scalar quantity or a vector quantity in red. In fact, you can get given a list of physical quantities and asked to classify whether it is a scalar or a vector. उसमें distance and displacement दोनों आ सकते हैं, and this is a similarity between them. Okay, so this is like in a nutshell. Okay, so just to remind you, on a lighter note, this is what even we have done. Although I am a teacher today, we have been as naughty as you are. Okay, so if this is my classroom, this is the washroom, the toilets. Okay, here is the library, and here is the admin office, and here is the staff room. Okay, and the playground is somewhere here, right? So whenever it was the PT period, whenever it was a physical education period, we would always go rushing out of the classrooms directly like this. Okay, and this is the path, this was the only path, right? Okay, but while returning, we were least interested on, this was the ground, right? Okay. And after the PT period, जब PT period खत्म हो जाता था, एक तो वैसे ही हम, we were like puffing and panting, okay, और class में जाने का तो कतई मन नहीं करता था, so we would simply go to the admin office to ask if the new uniform is available, go to the staff room to check if there is any proxy, and then go to the library to check if the reference book is available, and then go to the washroom, okay, and then we would go back to the staff room to check if the teacher wanted us to carry some books back, and then go to the classroom. So can you see? Displacement तो यही है. Displacement तो अभी भी यही है बच्चा. From classroom to playground. Okay? But, so this is the shortest distance, black वाला. But, जब जाते थे, खेलना है, इसके लिए, this was the path. And लौटते समय. So let us answer the questions related to distance and displacement. We begin with the question in your textbook. It is the in-text question on textbook page 100. So you may just open your textbooks to page number 100. The question reads, an object is moved through a distance. It is moved. Can it have zero displacement? अगर move हुआ है तो distance तो cover किया है. So क्या displacement zero हो सकता है? If yes, support your answer with an example. Well, let us assume that you are running a 400-meter race. Generally, a 400-meter race in a school is along a circular path. And this is the beginning and the end. Okay? So, you must have run the race you ran and reached the finish line, and the distance is 400 meters. So you can claim you moved that much of distance, okay, through a distance. But what was your initial position? This A. And what is your final position? You have come all the way back to A. So आपका initial or final position same है. So according to the definition, what is displacement? The shortest distance between the initial and the final position. That means the displacement is zero. So what is the example? When you cover a circular path and come to the starting point back, then the displacement will be zero. take one more example. If you have been swimming, you must be knowing that if this is the swimming pool and when you move, you start swimming from here. Let us say it is 200 meters, the distance. Okay, so you started moving from, let us call it as A, position A. You moved here, so you swam all the way to reach B. So this is 200 meters. A to B is 200 meters. And you moved back. You moved back to cover one lap. You moved back. Okay. So you move from B to A 200 meters. So your distance, the distance would be 400 meters. But the displacement, आप A पे थे और A पे आ गए. Your initial position was A, your final position is A, so there is no change in position. So your displacement is 0. In short, if you travel whatever distance you want and you reach your original position, then the displacement will be 0. So the answer is indeed yes. And these were the two examples to confirm that. So, let us go to the second question on page number 100 of your textbook. I always advise the students to read the question twice. So, I request you to read it once, all by yourself. Now, it says, the farmer moves along the boundary of a square field. So, let us highlight certain keywords. He moved along the boundary of a square field of side 10 meters in 40 seconds. Now, what will be the magnitude? We are interested only in the magnitude of the displacement of the farmer at the end of 2 minutes 20 seconds. I would like to draw your attention to the fact the square is of side 10 and he moves along the boundary in 40 seconds. So let us draw a diagram. Well, let us assume that this is his farmland and let us call it A, B, C and D. So each side is 10 meters. And he has moved along the boundary. This is a catch in the question. He's moved along the boundary, the entire perimeter in 40 seconds. So it is 10 plus 10 plus 10 plus 10, 40 meters in 40 seconds, right? So we have got 40 meters in 40 seconds. Therefore, it will give you 10 meters in 10 seconds. Let us see how many seconds we have in this much time. So it is 2 minutes. It is 2 minutes 20 seconds. Well, 2 minutes, 1 minute is of 60 seconds. So 2 minutes means we have got 2 into 60, 120. So we have got 120 plus 20 is equal to 140 seconds. This is the total time with us. So, mind you, he moves 10 meters in 10 seconds. So, let us count it out. Then I will tell you a shorter way. So, he moved 10, 20, 30, 40. Back to it. 50, 60, 70, 80. 90, 100, 110, 120. Now we have got 20 seconds left. 130, 140. So he started from A, but he ended at C in 2 minutes 20 seconds. So let me remind you the definition. The distance is the length of the path he took. But we are interested in the displacement. Displacement is the shortest distance between the initial and the final position. So his initial position was A and final position is C. So whether he can walk diagonally or not, we have got to find the length AC. Fortunately, they said it is a square and hence this is a right angle. So we can use Pythagoras theorem. So we can say in triangle ABC, angle B is equal to 90 degrees. Therefore, AC square is equal to AB square plus BC square. And that gives us 10 square plus 10 square. That is 100 plus 100. That is 200. I'll repeat, 100 plus 100, that is 200. So AC is going to be root of 200, which can also be understood as 2 into 100. Hence, we can get AC is equal to, the root of this is 10 and this remains inside. This 2 will remain under the root. So we get 20 root 2 meters. Hence, the magnitude of the displacement of the farmer at the end of 2 minutes 20 seconds, which we calculated as 140 seconds, turns out to be 10 root 2 meters. It is the shortest distance between the initial and the final position of the farmer. I hope you understood. If not, you can rewind and watch it again. So, this is the third question on page 100 of your textbook. It asks, which of the following is true for displacement? Mind you, displacement is a vector. And the statements are, the first one, it means displacement. So let us read it as displacement. Displacement cannot be zero. Do you remember the first question on the same page where we actually gave two examples? So let's have a quick recap. Let's say A and B are 2 points at a distance of 100 meters. You move from A to B, and back to A. So the distance may be 100 plus 100, 200, but the displacement is 0 because you started at A and you ended at A. So your initial position was A and final position is A, and hence because they're the same, you're back at the same point, the displacement will be 0. It can be 0. Let's have a quick recap at the other point. We talked about a 400 meter race. How you start at A, you run the race and the end is also at A. So your initial position was A, your final position is A, so the total displacement will be 0. So it can be 0. It can be 0. Okay, so this statement is not true. It is not true. Or it is false. Well, let us look at the second statement. The second statement says its magnitude. Now, its magnitude means the magnitude of the displacement. Displacement's magnitude is greater than the distance travelled by the object. Well, the answer is very obvious. Still, let's look at the definition. The definition says that displacement, this will be a nice revision of the definition. Displacement is the, if you remember, shortest, mind you, shortest distance between the initial and final position of a moving body. When the definition itself says it is the shortest distance. There is no way that it can be greater than the distance traveled. Okay, at the most it can be equal, and that also in case you are traveling along a straight line. If a body is traveling along a straight line, then the distance is equal to the displacement. Otherwise, displacement will be the shortest distance. No way can it be greater. So this is not true. Woohoo! If I had two statements in the test and if I get both the answers as not true, I would have been doubtful about myself. But can't help it. So these are the answers. So this is the first sum of the exercise on page 112 of your textbook. It says, an athlete completes one round on a circular track. The shape will make a lot of difference of diameter 200 meters in 40 seconds. So he makes one full circle in 40 seconds. What will be the distance covered and the displacement? So we want both at the end of 2 minutes 20 seconds. If you remember, we have the same timing in the earlier question as well. Okay, since it's a circular track, let us draw the circle and get the things clear. So let's say that the athlete started from A and ended at A. Okay, so the length of the path which he took, the distance, for that we will require the circumference. Okay, so let us first calculate the circumference. Well, the diameter is equal to 200 meters. The diameter is 200 meters. So the radius would be 200 by 2, that is 100 meters. And the circumference would be 2 pi r. You could have skipped this step and done it with pi d. Okay, so it's going to be 2 into 3.14 into 100. So this 100 balances this decimal. Like if you remove this decimal, you have 100 here. So they get cancelled and eventually the answer is 628 meters. So the circumference is 628 meters. That means when he starts from A and comes back at A, he has covered 628 meters. Okay. Now, the time, and that requires 40 seconds. Let's calculate the time. The time is 2 minutes and 20 seconds. Well, 1 minute is 60 seconds. So 2 minutes is 120 seconds. So it is 120 plus 20, that is 140 seconds. Right? Okay, so we will transfer the data over here. So one round is the circumference, which is 628 meters, and 2 minutes 20 seconds is 120 plus 20 seconds. Right? Now, to solve this further, I need to rub this. So what we're going to do is, first we'll calculate the distance. Okay, so he takes around, we have to find out how much distance does he travel. So how many rounds? So he takes the first round in the first 40 seconds. So 40 seconds means one round, right? But that is more than 40 seconds. So in the next 40 seconds, he takes the second round. The circle appears to be smaller, but that's just to distinguish between the first and the second round. He is running on the red track. So another 40 seconds. Okay, so this is 80 and we have 140. So we still have time, right? And the next one is another 40 seconds. I repeat, the track is the same, children. वो लाल track पे run कर रहा है. He's running on the red track. This is just to convey. So that is another 40 seconds. So let's see कितना time हो गया. 4 3s are 12. So 120 seconds में 3 rounds. Complete rounds. अब उसके पास 20 seconds है. He has 20 seconds. 40 seconds, 1 round. So 20 seconds, half a round. So in the 20th second, I will show the path on the outer side. So on the 20th, during the last 20 seconds, he covers half the circle. So this, let's say he reaches B. So this, the dotted one, is a semicircle. So AB becomes the diameter. Diameter. Right? Okay. So let us calculate the distance. The distance. So we will cover this again. So for the distance, he covered 4 rounds. He covered 3 rounds and half a round in this 20 seconds. So 20 seconds was half a round. So 3.5 rounds, and each round was 628 meters. So let us simplify it. So 35 upon 10. I was trying to adjust that decimal into 628. So 5 7s are, 5 2s are, 2 1s are, 3 1 4. So let us multiply 7 with 3 1 4. 7 4s are 28. 7 and the 7 and 2 carry over. That gives us 9. 7 3s are 21. So it is 2198 meters. तो ये 3.5 rounds में, do you understand? 3.5 rounds में उसने cover किया distance 2198 meters. Now let us go to the displacement. Displacement, if you remember the definition, is simply the shortest distance between the initial position A and the final position B. Well, 20 minutes में उसने आधा circle लिया, semicircle. So this is a diameter. So the shortest distance is displacement. Displacement is the shortest distance, that is A to B, regardless of the fact that he can cover this or not. Okay, that is equal to the diameter. It is equal to the diameter, so it is 200 meters. So as we saw in the earlier question, the displacement is not greater than the distance. It cannot be. Okay, so we have the answer. The distance covered in this much time is 2198 meters, and the displacement, the shortest distance between the initial and the final position, is 200 meters. बहुत नाइंसाफी है, बेचारा इतना दौड़ा 2198 meters और हम कह रहे हैं displacement is 200 meters. That's it.